So this is lesson number 6, 12, and this is about more of E. And so the learning target is I know E is an irrational constant like pi that has a value 2.718. So last class I showed you how to do the work where how did the E existed, and today we will do directly the problems based on this. So this is practice problem question number 1. Okay, so we do know that E is 2.718, and I'll just keep this much. And if we try to graph that E raised to x, remember this is 2 is less than 3 and less than 2.7 is between 2, 3. So the graph of this is going to be 2 raised to x, and this will be 3 raised to x. And then another one, this will be 2 raised to x. So this one in between is always the E raised to x because 2.7 is between these two. Now put the following expression from smallest to the greatest. So which among this is the smallest? So so we'll try to keep 2.7 is almost like, let's put it like 3, right? So if I want to do this, we'll put it like 3 raised to 3 approximately, and 3 times this is like 27. This is 4. This is 3 square is 9, and this is 2 times 3 is 6, and this is 3 times 3 is, sorry, uh, so I'm gonna keep it like 20. Let's see which one is, like I'll put it 27, but the main thing is smallest is 4, so 4 is the left, then comes the 6, so then comes the 9, and now the problem is we need to know which is, even though I wrote it 27, but remember this is not 3, it is 2.718 raised to 2.718. And this one is 2.718 raised to the 3's. And you can clearly see if the base is the same. So this is the same base, but the top one, this number is less than the 3. So the whole, this big number, this left side will be small, and this will be large. So this one E. So this will be e raised. I'll put it like e raised to e will be, and the this will be the biggest, e raised to 3. 9 is e square. 6 is 2e. This is 2e. And 4 is 2 square. So that's how it is. Hope that helps. Let's go to the next. So question number 2, I already explained to you. We need to know what is this, what is this, and what is this. And you can clearly see 3 because 2 is less than e and the less than 3. With 2 raised to x will be smaller than e raised to x is smaller than 3 raised to x. The graph, this will be up, then this, and then this down. So this will be 3 raised to x, this will be e raised to x, and this will be 2 raised to x. So that's how, sorry, 2 raised to x. So easy, right? Let's go to the next one. So this question, if you see given to you, and you need to select which is the right answer. Whenever you have a function like this, remember a raised to b raised to x, the exponential function. This is always the case when the input is 0, it's like a, output is a, and this is the factor, b is always the factor. Okay, now, so is the a correct? The y-intercept the graph, yes. So when it is 0, so this number is a. So on the graph, if you see something like this is like 100 here, 100. That's the main point. The value of f increases when x increases. Like if you say x increases, this one says the graph goes something like this. So is that true? If you see here, there's a minus. Look at that. There is that minus. So e raised to minus x. So the graph, if you try to the graph on the decimal, it says the graph of e raised to x is this one. So this is e raised to x. But because of this minus, what does take place is the graph goes this way. See? It flips over the flips over the y-axis. Like the graph goes this way. So it decreases. You can clearly see. Let me take this all this and make a nice one maybe like this. So this is e raised to minus x. And basically why that is because if you see 2 raised to x, what is 2 raised to x? Basically means the graph is this way. But if I write 2 raised to minus x, can be written as 1 over 2 raised to x. See? Because of the minus, this 2 which flips. 2 raised to minus 1 is 1 over x, 2. So this is a fraction, this base factor half is between 0 to 1. And that's why the graph, this is when it is less than 1, the graph exponential function decreases. You get this way. Okay? So this is 2 raised to x and this is 2 raised to minus x, which is same as half raised to x. So whenever it's a fraction like this, so this is how it looks like. So if we go back, that is wrong. So this is correct, this is wrong. What about when x is minus 1 is a little less than 40? And for this, we'll have to plug it in and see what's happening on your Desmos. So you substitute x is minus 1 right here. So it's like 100 times e raised to 1, right? So 2 negative will make it positive because minus of minus 1, which is, so this will be 100 times, and e is 2.7182, and you can see because of this 2, the decimal here moves 2 places. So we get 271. And he says less than 40, how can it be? And you can also see, this is like, you can use your common sense and say, since the graph is, when it is 0, it was 100, right? This was 100. So if it is minus 1, so this is minus 1, he's saying it should be less than 40. So this is 40, this is 50, let's say this is 50, and that is 40. So to the left of 0, 1, 2, 3, 4, and the graph is decreasing. So if it is decreasing, it's like this, right? So at minus 1 should have been this point up. So how can you say less than 40? So that itself is stupid, right? Or you can do plug in and say, hey, that number is 271 again, which is quite bigger. So this is not correct. What about this? If you plug in x equals minus 5 right here and see what's happening. So let's put x equals 5 right here. So it is 100 times 2.718 raised to the 5. Okay. And he says it should be less than 1. So there's a minus sign. I put a minus sign, and you may get confused with this. You can always put it on the calculator. So let's take Desmos calculator here, okay, and take this off and put e to the power. So it's 100 plus 100 multiplied by e raised to the power 5. You get, sorry, forgot to put a minus sign. So you get 0.6, and that 0.6 is this is 0.6 is less than 1. So that is correct also. So this is correct. What about f is never 0? Now when you have 100 and e raised to minus x, remember this is e raised to minus x. So exponential is this part it will never be 0. And we can see also if I try to take this off and put y equals y equals 100 e raised to the power minus x. So this is how the graph will look like. Okay? And you can see here clearly the graph start from up and goes all the way down. Even though it looks like it is zero, it is not. Um, and you can put a best is why don't we put some number maybe and say okay -2, -1, 0, and then put 100 and see what happens. See? So there's always some number. So let's put it like a 10 maybe. See? So when I put x equals 10 here, it is 0.004. It becomes a very small zero. Put 20. See? So so they gave you in the form of scientific notation, but it's like a lot of zeros there. And then you can see 30, put 40, put 50, put 60, and you'll see it never becomes zero. It becomes a very small number. So this part, so almost like showing it is zero, but it's not zero. Hope that helps. So this is correct. So let's go to the next. Okay, this is question number 4. You have to use the calculator in this case. I want you to pause for a while and understand that there is a dollar here, and you have different situation. If it is 100%, so you put a so this 100% is 1, right? So I'll put a 1. That's why there's 1 there, and the answer is 2 because 1 times. So this answer is going to be 2. The next one is they say okay, if it is 10% and you put for 10 years, so this is going to be the 10% is 10 divided by 100, which is 0.1. So that's why you see this point is 1 plus, and you put in the calculator and see what's happening. Let's put 1 plus zero point 0.1 on the calculator and see what happens. Okay, let me take this off. This time I'm going to put 1 plus 0.1 and go outside and put 10. You see? You get 2.59. And so all this number 2.55937. So here you're going to put 2.597, whatever that. Next you put the same thing. This time you're going to put 5%. Now 5% meaning 5 divided by 100, which is 0.05. So that's what you're going to put in the calculator for this part. But for 20 years, so you put 20, so go up there, and now this will be 0.05. Go up there and put back and put 20, and so you get 2.65329, and I'll go back and write down that number. So put the number as 2.6539. Okay. Likewise, I want you to do the rest and fill the table. So don't depend on me, everything that I'm showing. I'm just showing what's happening here. I want you to also look at uh, whatever the percentage is here, it goes here in the second number here, like see this part, and outside is this number. So we'll see that in the next question. And likewise, you will see this number as you go on doing, see this number 2, then goes become 2.5, 2.6, maybe 2 point here, 2.69, and maybe 2.705, maybe 2.72 something, and then 2.7, sorry, 0.8. And eventually what happens is as you make this interest very small, and this you do frequency per year, compounding many times in a year, this number is almost going to become 2, which is called E, right? 2.7182812, whatever that is. If you want to know exactly the answer, let's go back here and put here E. So when I put here, you already get this answer. So it is 2.718288182. And it's just an irrational number. There's no pattern. It just goes on, non-terminating. It's just endless kind of a number. That's all it is. And I hope that you. So they're asking, will it be above be zero? No. And how will it be more than three? So there's one question. They ask, will it be ever be more than three? No, it is going to be at the most. This is two. I think 2.7182. I'm gonna remember is E equals 2.718. I think that's enough. Of course, there's a two, but this number can never, now will never be greater than three. So there's a question they're asking is, will this be? So this is the natural number. Okay, look at this question now. This is the function is given like this: 1 plus x raised to 1 over x. So what do the values of f behave? F behave for small, positive, and large value. So they want to check. Last time, you remember in the classroom, I was showing it. If it was 1 plus 1 over x and raised to x, and we see in the graph there, this was 3 and that was 2 and this was 1. The graph was, so the graph was this graph. There was a line. Remember, there was asymptote this way, which is 2.7182, that is E, and the number. Now, if you see this you can't have x cannot be zero, right? So the domain is you can't have x equals zero. So if it is zero here, there's no answer. Okay, but the graph, so it will be like empty space here. So the graph goes like this, and it goes on and on and on, so almost touching the horizontal asymptote, which is y equals e here. So hope that so this is the horizontal asymptote, but the graph of this part that we've seen on Friday is there's a hole here because you can't put x equals zero, and then it goes on increasing. So it goes increasing faster here, but then slows down. See and later on in the pre-calculus, you will see this is the at what rate is the graph increasing. Here the rate is very quick. See this? If I try to draw the tangent like this, it goes on, becomes smaller. So in the beginning it is fast, but then it slows down. That's what we did. But here it's just the opposite. So how the graph is. So let me take this off, and so how this graph will look like. So the best is put x-axis. Let's graph this. And if I put a zero, we can't put zero for this also, right? But then let's say there's a 3, there's a 2, and there is a 1, and there's a e, which is 2.7182. So somewhere here is 2.71, not half. This is almost like, okay, this is half. It is a little bigger. That's the line. Like, okay, that's how it is. This is how it is. So, and you will see graph. There's going to be a hole here, and the graph is going something like this. Like this. And you will see there's a horizontal asymptote right here at 1. So this goes almost closer to like a 1. You can check this. Okay, now, and go back there. This graph is, so let's take this off everything. I'll take a separate, there's more than take a new one just to let me take a new one. Let's put 1 plus x, and then go up and put parentheses and divide by x. Close it. See? Then you get something like that. And you can see that there's a hole here. I want you to really get that part because you can't put a zero, right? I also want to put y equals 1 because and put it like a crescent hole, and you change it to dot, and you can see and this part. See, if you want to have more of the on the right side, you can go to the setting and change this to maybe a 50 just to get an idea. See how this graph, which is empty here, I don't want too much on the y-axis, so make it maybe I think I made a mistake here. This should be 10, 50 here. And then I want the y, I don't want too much so big. I think 50, not 15 also. Let's put it like 5. Okay. And why do we even need so much of -3? I'll just put it like a 0. And this looks so beautiful. Okay. So when x is 0, you can't put, let's put a table for it. Mhm. So x is 0 is undefined and then goes on. So let's put 3, 4, 5, 6, and 10, 30, 40, and like that. It goes on decreasing, almost becomes equal to 1. That's all it is. Hope that helps. Question number 6. I want you to try us. It seems 1990, the value of the home in the neighborhood doubles, right? 16 years. So I would just do a table like this in 16 years, right? So that's a 0. Somewhere here is 16. So every 16 years, and the house was 136,500, and it doubles. So that's the double. Like it becomes 0, 0, 5 plus 5 is 0, 1, 12, 6 is 12, 3, 1, almost like here, right? So it doubles. So what is the growth factor for this is, what is the growth factor? Is 2. B is 2. That means if you want to create a function for this, is f of x is the beginning here 1365 and then times 2 raised to 2 raised to, so here the function every 16 years. So if you want to know every year, so this is like this is for 16 years, right? This is for 2. But if you want to know every year, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So if that's the case, then you have to divide. So if I put t number here, this becomes 16. So that's like each year. So be careful. So, so when you say b equals 2, so this 2 is, so this 2 is growth factor. Let me put like a b is 2. But when you talk about our regular function of exponential function is b raised to x, that x is 0, 1, 2. So you want to know each increase in 1. So this becomes what you have in the beginning is 13650, and then the growth factor is 2. This 2, okay. So that 2 is for 16 years, but you want to know every year, like so it's like 16 times. So it's like 1/16. Each year becomes 1/16. That this B, uppercase B is 2, but the lowercase, that's what I'm trying to always, I've been trying to, so this B, this is the growth factor which I'm talking about it. The 2 is for every 16 years. But you want to know for each year, it is 16 like this. So what is the value of this in 2000? So it says in 2000, right? So this was in 1992, and this 92 plus 16, if I add 16, this will be 800 right? This is 2000. This is the year 2008, right? So they're asking you in between, what about 2000? So what about 2000 from here to 2000? Now, if you see 1990 to 2000 is 8 years, right? So what you do is this part you put 8. That's it. So simple. So what will be this answer? It's like 2 raised to this answer is. So there you go. You just put this on the calculator, get the answer. The next question, write a representative function of t after 1992 each t years. So if it is year, you're already done. So it's like you just multiply t. So the already what I showed you. So just take this off. And that's the t. This for each year after t years. Write an equation of the function in d years. Now this is t, right? So what I will do is because they're asking every decade, now I have to change this. So this whole thing, okay, let me write on the left side. So if this function is for each year, I'll make it every decade, right? So I'll put D stand input is decade. 1365. Okay, I forgot to put 0. And now this is you want to know every decade, so it becomes 2 raised to 1 decade is 10. So I put 10 raised to 16 and put a D. That's all it is. So if you see this clearly, in this case, if you see this T is 0 year, 1 year, 2 year, 3 year. So we can get for 10 years, this will be the each decade, that's going to be like a growth factor. So you want to know function, write an equation. So this becomes the equation for each decade D here. Okay, so let me make it nice and clean. It's too much of stuff here. Okay, so this thing is, remember again I repeat, the growth factor was 2 over 116. This was for each year, right? This is for each year. But why this 10 is put? That's 2 raised to 16 for each decade. Each decade. 10 years, right? And then this D is, what is that D stands for is, D is 0 year, 1 year, 2, 1, it's like 1 to 1 decade, 0 decade, or 10 decade. Sorry, 1 decade is 10 years, 2 decades is 20 years, 3 decades is 30 years. That's all that means. So you're going on plugging in and you get this equation for every decade. So much of confusion. Hope that helps. Question number 7 is write two equation, one in exponential form and the logarithm form. So to what exponent do we raise 5? So it is like 2 5 raised to what gives you 625, right? Clearly, you do know that this the only option is 6. It is 4. Why? You can check 5 times 5 is 25, right? And that means if you multiply 5, 4 of them, 25 times 25 is 625. So that's one. But if you want to write in the logarithm form, so if you want to write in the logarithm form, 5 raised to 4 is 625. It's asking like you don't know that. Let's see if you don't know. It's like logarithm of 625 to the base 5. And it's asking a question, how many times do you multiply 5 to get all the way to this? And your answer has to be 4. And you can check with the calculator. I just want to make sure you get understand. If I go back here and take this off everything and put here, go right here, get the function log. Yeah, this one, and I put here 5, and you want to put 625, right? And if you check, you see you get 4. It just means that 5 raised to 4 is 625. That's all that means. Hope that helps. So one is doing with the calculator and you writing to different. Let's say the another one is asking you, what is this? What is logarithm Base is 3 and this is 25. Is asking, hey, what is this? This is the logarithmic form. Change it to exponential form. Ask a question. 3 raised to what gives you 27? And 3 times 3 times 3 is 27. So there are 3 3. So that's it. You're done. So there's a question. Claire is saying, hey, this answer is minus 1. Do you agree? Yeah, come on, let's check. If you don't agree, what it means is there's no number means it is 10 here. It's asking how many times do you multiply 10 to get minus 1? Okay, we don't know. So we don't know, what do we do? We just put it in the exponential form. The base is 10, so we put 10 raised to what? So we don't know what it is, right? Sorry, so the minus 1. So we put e raised to minus 1. Okay, let me do it one more time. I think I made a messed up here. So let me do one more time. So first one is, see, this part is logarithm to the base. Do you agree with this answer? Is that's what the question is. If you change it to the exponential form, this is the base raised to this number. Do you believe this? Yes, because this means it is 1 over 10 is 0.1, correct? That's perfect. What about this? Do you agree? And this one, logarithm to the base 10 of minus 10, right? Equal. What does this mean is minus 10, or you say, okay, this is the base goes and you you push this up at minus 1. Do you agree with this? This answer is 1 over 10 and this answer is 10. How can they be equal? No. There's another way to also to argue on this is saying that, hey, you can't have a log of negative because so this itself is weird. You can't have logarithm of negative number. So what I'm trying to say is the domain of logarithm cannot be log is always positive. Question arises why is because if you see 2 2 raised to x, y equals 2 raised to x is so this answer when we graph. So this part. So if you see this, this is always positive, it's above the x-axis. This is y-axis, this is 0. So anything, this is going to be positive, right? So when you flip, when you write a logarithm of this is this y to the base 2, you get x, right? So, okay, so if you see this, this is y, right? This is y is greater than 0. So this y has to be greater than 0. So how can you even think of having a negative here? No, that's stupid. So that's what I'm trying to say. You can't have logarithm of negative to whatever the base, and you can't even have the base as negative also, or you can have a 1 and 0. So the reason is when you talk about exponential y equals 2 raised to x, this is defined. Suppose b raised to this b that you can think base cannot be 0 or it cannot be minus 1 negative, or it can. So that's how you can't have a negative x. That's how the exponential function is defined. It has to be 1. Remember the b stands for 1 r. So basically what I'm trying to say, if you have a logarithm of something here and something here, remember this cannot be 0, cannot be a 1, cannot be negative. So that's one thing you have to, and this part cannot be negative also. So you have to take care of it. So the domain of this is anything x, but x should be greater than 0. All real numbers greater than 0. And the base at the same time should be greater than 1, and also it should be b should be, sorry, b should not be 1. B should be greater than 0. That's all it is. So hope that helps. All the best. Done.